Yeah, welcome everyone to today's webinar on the topic of IoT Edge Computing 2020, Architectures and Trends. This webinar is co-presented by IoT Analytics and Stratus Technologies. And just a few housekeeping items before we get started. It's a 1-hour webinar. We have a moderated Q&A at the end. All of you dial-in participants are muted at this point. Should you have any questions, please write in the Q&A on the Q&A button. Leave your question at any time. If you have any problems, leave a message in the chat. A recording of the webinar will be made available to everyone attending. And at the end, we will ask for your feedback, how this webinar was, how satisfied you were. So please fill out the survey. That would really help us. Thank you. Yeah, quickly to get started, my name is Knut Lasselüt. I'm the CEO and founder at IoT Analytics. I've been doing a bunch of IoT related research in the last years. And with me on the call today is Matt Wopata. He's our lead analyst for everything industrial IoT and the author of the upcoming Industrial Edge Computing report. Also with us, as I just mentioned, Stratus Technologies. We have Jason Andersen, who is the Vice President of Strategy for Stratus. And he brings 20+ years of experience in various market delivery, both on the cloud as well as on the on-premise side. And with that, Jason, why don't you quickly get started and introduce Stratus? I am not able to hear Jason. Jason, is it just me?
How about now? Can you hear me better?
Now it's good, Jason.
Okay.
There we go.
Let's go with that. Sorry, there's a little bit of microphone trouble. Stratus is actually a company that's been around for quite some time. We're now in our 40th year of existence. We're headquartered here in the United States. And for our entire company history, we've built mission critical platforms, starting out in industries such as telecommunications. But over the last 10 years, our business has really shifted towards what we're now calling edge computing. And as you can see here, we have a number of nice scenarios where we support things like water, transportation, energy, as well as manufacturing. And we have a lot of customers, and we'll have a lot of great stories to tell a little bit later on in the presentation. I think I'm going to be turning it over to Matt, right? So.
Can you hear me?
Yes.
All right. Very good. So briefly about IoT Analytics, for those of you who don't know, we're a market research and consulting company that helps customers understand the market dynamics of IoT and Industry 4.0. And our work products are broken up into 2 categories. So one being reports, so market reports, and then we also offer bespoke research services and go-to-market strategies and consulting and the like. So with that, I think we can get into the bulk of the presentation. So a quick overview of the agenda for today. I will be handling sections 1 through 3, where we'll talk about the evolution and definition of the IoT Edge, do some market forecasts and trends, and then talk about use cases and edge architectures. And then at that point, I'll hand it over to Jason, who will share with us some case studies from Stratus customers, discuss some best practices around the edge, and then I'll take over again, and we'll do a brief outlook for the future of IT spending, and then commence with the Q&A. So without further ado, we'll get started. And as a starting point, we want to take a look at the public interest in the edge. And you can see from this Google Trends chart that edge has become increasingly popular, especially over the last 3.5 years. And we've identified a number of things that we think are driving this trend, 10 to be precise. And we discussed these 10 trends in depth in the previous webinar that we did with Bosch. So I think Elise is going to put a link to that webinar here, but we're not going to spend time discussing those today. If you want to learn more about these 10 trends, please check that out. But this is just to give a little bit of background as to why we're talking about edge today. If it wasn't already apparent that edge is a hot topic, there's some quantitative data to prove that. So, and when we talk about edge, obviously we need to come up with a definition, because there are lots of definitions out there for what the edge is, and oftentimes it depends on your perspective. But from IoT analytics perspective, edge computing is a term used to describe intelligent computational resources located close to the source of data consumption or generation. And before we go on, I want to double click here on intelligent real quick to describe what we mean by that, especially within the industrial context. Edge has been around for decades. You have industrial controllers and sensors and robots and all sorts of things that are running on the edge that are performing automated tasks and things. But from our perspective, there's a sea change happening where those edge devices we don't consider to be intelligent. And that's because they often run on proprietary operating systems, running proprietary software, and the hardware is tightly coupled with the software. And so when we're talking about the intelligent edge, we're talking about edge computing devices that have the ability to run multiple types of applications on them, often running a Linux operating system. So just wanted to get that definition out there to start. And now to look at the definition of edge from a more graphical perspective, we'll go to the next slide. And at the highest level, we'll split the different types of compute resources up into the cloud and the edge. And looking at the cloud first, you can see that most of the things running in the cloud are running data centers, and they're organized by geography here. So you have a national, a regional, and local data centers. And those are the three types of cloud that we have defined. And then if you want to look at the edge in a little bit more in depth, we have identified 6 different types of compute resources that are available on the edge, starting from the cell tower data centers at the highest level or closest to the cloud, all the way down to the sensors and devices. And we lump these edge compute resources into 3 categories. So you can see we have the thick edge, the thin edge, and the micro edge. And this has to do with the amount of compute capacity that these different types of edges have. And depending on what your use case is, you'll use different types of compute resources to achieve your use case. And we'll talk about that a little bit later in the presentation. But defining the edge is we try to make it a little quantitative here to look at the typical compute characteristics at the different levels of the edge. So the further out to the edge you are, if you will, the closer you are to the data source, and the lower the latency will be between the compute resource and the device that's generating the data. So if you look at, for instance, the sensors and devices, those compute resources are often the sensors themselves, so they're literally millimeters away from the computational generating device. But if you look at the cloud, on the other hand, the cloud data centers can be kilometers away from the device that's generating the data, which also results in a typically higher latency. So that's kind of our full diagram of what we consider the edge. And to highlight what we talked about on the last webinar, we looked at the thin edge. So looked at controllers and networking equipment. And the focus of this webinar is going to be on the thick edge. So computers and on-premise data centers. We're not going to talk about cell tower data centers for this presentation, mostly because that's still sort of an emerging edge when it comes, especially in the industrial perspective. That may change in the coming years as private 5G and private LTE becomes more popular. But for the focus of this webinar, we're going to keep it on the computers and the on-premise data centers at the edge. And even more specifically, we're going to look at the thick industrial edge. So there's many different verticals in which edge computing can be deployed, from anywhere from your Alexa at home to an industrial site. And we're going to focus on the industrial sites here because that's the focus of the market report that we've been working on. And I think there's some very unique characteristics that the industrial edge has that requires some more attention. And with that, I think we've laid out the foundation for defining the edge, and now we'll go into the market overview and trends section. And so, as I stated on the previous slide, the market that we're focusing on in this data is the industrial edge computing market, and more specifically, the intelligent industrial edge computing market. So if you look at the title there, it's kind of a mouthful, but I think it's important to qualify what we're looking at here. So the industrial edge computing market reached $11.4 billion in 2019 and is projected to have a CAGR of 70% through the forecast period. And just to provide even a little more detail on what we mean by industrial edge computing and kind of reinforce the fact of what we're looking at. Remember, intelligent rather does not include the quote unquote dumb field devices that have been in the field for decades, that run proprietary software and on proprietary hardware. So think DCS systems, PLCs running ladder logic code for the most part, those are excluded from the intelligent edge. The industrial edge obviously means compute resources deployed in industrial environments. And then the term edge is important here as well, because we are not considering the software and the infrastructure that is becoming an increasingly important part of the industrial automation space that is hosted in the cloud. And to kind of articulate this a little bit more, we've put some ovals here on the top part of the graph that show what the proportion of the intelligent industrial edge market is of the overall industrial automation market. So you can see, we think that the industrial automation, the intelligent industrial edge is 7% of the overall industrial automation market, and we can anticipate that that will become an increasingly large portion of the overall market as the growth rate for the intelligent industrial edge outpaces industrial automation. So if that wasn't enough, we'll now move into the trends and challenges associated with the thick edge. So starting with the computers, one of the trends that we're noticing that's driving this adoption is that automation workloads are becoming decoupled from hardware and consolidating. So especially control and visualization workloads that have traditionally been associated with pieces of hardware and proprietary software, these workloads are now being decoupled from that hardware and oftentimes containerized in order to run on more intelligent edge computing hardware. And this picture on the right from Keba shows how HMI and PLC applications can run on top of a Linux operating system next to applications and even third-party applications from consumers running on both non-real-time and real-time software. The next, I think it's challenge that we want to discuss here is that once you have decoupled the automation hardware from the software, you need to be aware of the short product life cycles that are traditionally associated with IT equipment. So OT hardware, as we all know, can stay in the field for decades. And as these workloads are being decoupled from the traditionally from the OT hardware and putting on more intelligent compute resources, you need to make sure that the industrial PCs and the data centers that you're putting these workloads on will have that same support life that you as an end user have come to expect from the OT vendor. So just something to keep in mind. Now moving on to on-premise data center trends. The first trend that we've noticed here is purpose-built solutions. So edge application and IoT platform vendors are partnering with IT hardware vendors to come up with pre-integrated and pre-certified solutions that realize specific use cases like analytics and on-premise based IoT platforms. And by pre-configuring and pre-certifying these solutions, these vendors are seeking to reduce the maintenance and integration time associated with these systems. And so this example on the right is from our friends Stratus here, the FT server solution. They recently announced a partnership with Aviva, so the FT server is pre-certified to run the Aviva industrial suite of software. And one more trend on the industrial or on the on-premise data centers edge, and that is IT hardware being offered as a service. So both traditional IT vendors and cloud hyperscalers alike are starting to offer on-premise edge computing as a service. So vendors like Dell, HPE, and Lenovo now let you buy their equipment as a service versus having to deploy a large CapEx to buy a full data center. And we're also seeing this within the hyperscalers. So Amazon and Azure are now offering their own hardware that can be deployed in an on-premise solution as a service. And this is a picture from Microsoft's new Azure Stack Edge hardware. It's a rack-based server that has a Windows logo on it that you can stick in your data center and extend the Azure cloud on-premise. With that, I think that concludes our market overview and trends. And now I'm going to do one more section on use cases and architectures at the industrial edge. So this chart on the left shows an analysis that we did based on 138 case studies for the Industrial Edge Computing report. And you can see that cost reduction, the type of use case of cost reduction, was the largest group that we identified with 168 use cases. And you'll notice that cost reduction has 168 use cases, while the total number of case studies that we looked at was only 138. And that is because a lot of edge computing case studies realize multiple use cases. So you can do predictive maintenance and quality at the edge for a single case study. And this chart on the right is a kind of double click into all of these different, or these three different types of use cases to provide more granular information. And you can see that the cost reduction category has many different types of use cases associated with that. And the focus of the remainder of this presentation is going to be on these three use cases that are highlighted here. But before we dive into those use cases, I want to take one more step back and look at the types of architectures, edge architectures that are used to realize these. So this slide highlights the three types of edge architectures that we've identified in the research that are deployed to realize the use cases mentioned on the previous slide. The first type of architecture is an 100% edge architecture. So these are architectures in which there is no cloud backhaul. A lot of these systems are air gapped, and it includes at least one of the different types of edge compute resources in those architectures. The second type of edge architecture is a thick edge plus the cloud. And so this is when you have an on-premise data center and some sort of backhaul to a cloud-based or off-premise based edge computing resource. And you can have other types of edge computing devices on there, but to be qualified as a thick edge plus cloud, you at least have to have an on-premise data center and an off-premise cloud. And finally, the third type of edge architecture that we identified was the thin or micro edge plus the cloud. And so these edge architectures do not have an on-premise data center, but they have one or more of some of these lighter weight compute resources running on the edge and then sending data back up to the cloud for analytics or other types of use cases. So with that, we'll go to the next slide. We can discuss what the difference or what architecture is right to achieve the different use cases. This is a big question. So if I want to do a predictive maintenance use case, or if I want to optimize my production process, which edge architecture should I deploy? And our analysis of the 138 case studies unveiled that there really is no right architecture for each particular use cases. We saw a number of case studies that realized downtime reduction using 100% edge, but we also saw many case studies that used the other types of architectures. And the same applies for almost all use cases that we identified in the report. So the answer to this is really, it depends. It depends on the specific problem that you're trying to solve in the specific environment that you're trying to deploy your edge computing resources in. And I think with that, we have one more slide to show which case studies or which use cases Stratus is going to highlight when they go through their section, and they can provide you some examples of how value is created with these use cases using these different edge architectures. And with that, Knut, I think I'll pass it over to Jason at Stratus.
Yeah, and before we do so, I just want to remind everyone, you can ask questions at any time in the Q&A section. I've seen some questions come through already on the general chat to the panelists. So I would invite you to please use the Q&A button and put it there, because we have a better way of having it all in one inbox and being able to look at it that way. So keep your questions coming. We've already had some really interesting ones, which we will look at in about 20 minutes. And Jason, over to you.
Great, thank you. What I wanted to do was really walk you through some real world use cases of technology that's in deployment today. So this isn't, kind of early stage anything. These are systems and solutions that are being utilized right now. One of the more interesting aspects of the edge that we've been really working pretty hard on over, say, the last 12 months or so at Stratus is this notion that people would basically bring in very bespoke solutions into the industrial space. So they were generally pretty service heavy in terms of people beginning to assemble things, and vendors like machine vendors or people who build machines would largely kind of leave the compute. There was think of it as a line where they would say, I'm going to deliver up to the PLC, but beyond the PLC, it's really up to the local IT department. What we're seeing is a big change in the last 12 months in terms of attitude of the machine builders, who are now realizing that when they want to deploy more technology solutions bundled into their products, or they ultimately want to reduce the cost of building their machines by moving from proprietary PLCs to standard-based IT computing, there's this big change in mentality about how much compute is being deployed on individual machines. This particular use case is from a customer of ours named Bradbury, who build large metal shaping machines. So if you think about things like car fenders or highway guardrails, those types of things, these are large machines that sometimes can be 100 meters long. Ultimately, they sell these machines to customers who are in a pretty rugged setting. And what they wanted to be able to do was have the machines be more resilient and be able to deliver new capabilities over the life cycle of that machine, because the machine may be in place for periods of even decades. They also wanted to make sure that with the addition of all of this new compute, they wanted it to be just as reliable as their existing automation infrastructure, which is in general, as Matt pointed out, more sensitive to resiliency and more sensitive to things like latency than you see in traditional IT deployments or in cloud deployments. So they wanted to also ensure that would happen. So they partnered with us, and ultimately what we've done is deployed a hardened industrial software platform and industrial computing platform into the individual machines. And what that ultimately does is it makes it much more simple for Bradbury or one of their partners to come in and service a machine in the event of breakage. Makes it easier to diagnose and fix problems. Our compute devices are redundant, so therefore the downtime risk was eliminated versus just putting a standard industrial PC or gateway onto the machine. And ultimately what our discussions with Bradbury are leading to is how can they actually deliver a different type of customer experience to their customers. As the customer being an OT person, they're going through a lot of changes in terms of how they do their jobs, the demographics of OT around the world, and ultimately what their roles are. So there's this real opportunity for a company like Bradbury to begin to sell value-added services or position enhanced support offerings to these new IT users. So excellent case study. Like I said, a little different than what we, or kind of a new space for a lot of people, is how do we actually deploy compute into the machine itself versus at, say, the factory or the line level. The next use case is a little bit different. We definitely see also more what we'll call, ruggedized or outdoor types of deployments. And the midstream oil and gas market is actually quite interesting. And this is another customer of ours who is a liquid petroleum operator, and they have about 135 sites around North America that are responsible for taking gas out of the pipeline system, preparing it to be deployed either through local regional pipelines and or in the case of liquid petroleum, oftentimes it's being put on a truck or a train and being delivered to another site. Ultimately, throughput is a big deal here. And the reason that it's a really big deal is twofold. The first is technologically, the software that's deployed in these sites isn't very modern. So when you think about what Matt talked about earlier around workload consolidation, you need to really have a very powerful virtualization platform deployed on site to be able to continue to maintain and ultimately even secure these applications as they get older. So this is an older application, and quite frankly, there is no certification process for a new computer with this old application. So you need to use virtualization as a way to kind of extend the life of that application. Additionally, there was just a real need for standardization. Like I said, there's 135 sites around a couple countries. And quite frankly, there was a real challenge with being able to maintain all this technology out in the field, especially since we don't have IT people in every location in this case. Actually, in most cases where Stratus is deployed, there are no IT people at all on site. And what was happening is, in the event of a failure, or in the event that the software started to behave strangely, obviously there was a lot of failure with that. If something went down or if a process was interrupted, even without a system downtime, we really needed to the company really needed to scramble to get things fixed. And that was a real high cost for them in terms of being able to, have the site basically inoperable for a period of time. So what we were able to provide, or what a new edge computing solution was able to do, is give them an IT-like solution deployed in a very remote location. And really that was the main benefit. And what that did was it enabled better uptime and no unplanned events, where the systems would run, and frankly the systems running is what's managing the amount, the understanding of the amount of gas going in and out of a particular site. It also allowed them to really start to think about how they're able to connect sites better and what new types of applications could be deployed to better run their business. So when I talk about best practices, you'll hear about kind of capacity planning. And this is one case where a customer did a great job on thinking ahead of what their needs would be. And that would allow them to come back and say, we need a system that's going to, or a solution that's going to do this. Versus a lot of time in the industrial space, you'll see people buying a solution for a particular problem. And then when the next problem comes, they really have to just figure out how to kind of graph them together versus kind of scale in a very modular way. So that was another reason that this was a really powerful solution for this particular customer. Now to get a little even further out in the edge of what we'll call kind of the heavy mobile edge, for lack of a better term, we have Alan Weiss is a customer that builds shipping systems. So they work with companies that do all kinds of shipping, even yachting is one, but also heavy duty mobile systems. And in this case, they deployed our technology with a system that does dredging in Europe. So they, dredging canals. They're preparing canals for energy deployment, things like wind farms and windmills. This is a tricky environment, right? So just versus say a factory environment, you have even less critical IT skill on site. However, the other problems that Matt mentioned are even more pronounced here. So not just the ruggedization, but this is a situation where the life cycle of the product had a big deal. When Alan Weiss builds a ship, basically those systems go in place and they're in place for over 8 years before there's a refresh cycle. So it basically sits for 8 years, has to operate perfectly for that long. Typical IT solutions between software and hardware really aren't supported for that long a period of time. So it forced a midstream technology upgrade, which cost the customer and ultimately Alan Weiss money. There was also naturally some real issues in terms of what was going on and how the ships were deployed. They had multiple pieces of software. The architecture they had in the past wasn't necessarily optimized. So again, virtualization as well as redundancy helped them be able to begin to bring applications together and ensure that they'll work well over a good period of time. And then lastly, there are not only customer requirements in this case, because a lot of this work was for regulated industries and government. This particular solution that Alan Weiss deployed really needed to be able to stand up to the rigors of regulatory control as well. Like I said, what we were able to do with the solution, with the edge computing solution, is give them a platform that they could use for 8 years. Obviously in a ship, every square inch of space is optimized. So the fact is that through virtualization and through different form factors, we were able to bring the space required for the compute infrastructure down significantly. We also were able to deliver around environmental control and allowed them to do more centralized operations. So this really helped in terms of the labor cost control point of view that Matt brought up earlier. So like I said, we've had a lot of great experiences working with customers in all sorts of different industries and in particular scenarios. So over the last year or so, we've done a great job of really putting together a set of practices, and there's 10 of them in terms of how should you approach this and how should you get started, if you will. And this is available for download off our website. We do have a link here, but I'm just going to walk through a few of these just at a high level so you can understand what we're talking about. So as you can see, there's 10 here. If we just go to the next slide. The first one we talk about is really around TCO. A lot of times what we're seeing in these solutions and is that there's a real driver around cost optimization, right? So, it was shown in the study that Matt showed before as well, and we see that every day. And the truth of the matter is that a lot of people will automatically make a jump, especially as they're thinking about IoT versus the edge computing portion. And they'll think about, low cost devices, Arduino devices, or how can I, they start thinking about lots of little devices deployed all over the place. And the truth of the matter is that when you start to think about this problem, you really have to not just look at the cost to acquire, you have to look at the cost to manage this over the life cycle. If you choose componentry or compute componentry that's only supported for 3 to 5 years and you have an 8 to 10 year life cycle, that means you're going to have to refresh it at some point. There's also the fact of just other things besides just the cost to operate. There's also the cost of interruption, right? So one of the areas where we're most well known is around fault tolerance and fault protection. And as you can see here, there's this really interesting thing going on as you start to think about your edge IT and you see how much downtime a typical edge IT system allows. You start to say, well, geez, there's a big disconnect between the level of reliability I get out of something like my PLC, where I'm running critical software, versus what I get from something deployed in either a cloud or in a remote data center. And it's not just downtime; it also latency factors into that a little bit as well. So when you start to consider this, you have to really decide if you want to build out a solution that is going to be as resilient as your existing automation infrastructure. And if you do, then there's an additional cost with that. That is a premium type of industrial PC product, and you have to consider that and build that into your overall life cycle cost. So, like I said, it's fairly complex. It isn't as simple as buying an Alexa and putting it in your kitchen, right? This is obviously something that's going to require a little bit of thought, and it's going to have quite a life cycle to it. The other one we wanted to talk about is the idea of self-management. One of the things that has been very powerful in the enterprise IT space about cloud computing isn't necessarily the fact that you've saved money. It really actually has a lot to do with how agile people have become, because IT capabilities and practices have been standardized in such a way that they can be easily consumed and deployed. And the rules for that kind of go out the window with the edge, right? Because quite frankly, there's a long distance, you're talking about a last mile situation versus technology deployed in a data center with high speed networking. Generally, you're talking much smaller sites at the edge. Additionally, you have a set of resources who our finding is very willing to help out in terms of the OT resource being willing to help out and do work on site, but it has to be made and the technology has to be designed in such a way that it's intuitive, it's easy to work with, and quite frankly, it's easy to get set up and implemented. Because the OT resource, a lot of people hear the word OT versus IT and they think about the T part, right? They think about technologists. But the truth is that the OT resource has a very different skill set, and there's a lot of O behind what they do, not just T. So quite frankly, we have to make the systems such that they are able to manage themselves as best as they possibly can, because they don't necessarily have that IT backstop where they are. And we also recognize that as things become more connected, you go from the 100% edge to the thick edge or the thin edge. All of a sudden, the connectivity brings another level of complexity when it comes to things like cybersecurity and frankly, things like performance in certain high capacity situations. So ultimately, the last tip we wanted to talk to was that when you start to build this out, purpose-built is a great way to go versus general, especially at this stage of the life cycle of the edge. But additionally, you start to have to think about the future. So it's great to say, I'm going to go build an IT system that has these capabilities, but what about the next 3 or 4 projects that are coming down the road? How do I anticipate those and not have to kind of constantly, start over, right? Quite frankly. So in terms of that, some of the practice we give is around just kind of good old-fashioned capacity planning, and virtualization is really a game changer for you there. We have the ability to support multiple instances of the compute, and as Matt pointed out, even different types of computing needs can be met on the same system. I think that's so. When you start to think about that and think about capacity planning, you really start to think about what types of other considerations I have as I look to the future. What do I really need versus what do I need today, right? And these are the themes that we see come up pretty consistently. And again, this is available as a white paper from us on our website, but you start to see that people will come and begin to fully understand what reliability is, especially as they begin to transition from more kind of analog or hardware-based devices to more software-based devices. They really start to understand what reliability needs are. They also start to think about how we can service the system better. Can the system let me know if it's having a problem, right? And that's not necessarily the case across the board. In fact, we're finding that one of the more interesting aspects of reliability, not only reliability, but it's also predictability. If the system begins to behave in a strange way, for example, its performance begins to drop, or it's taking on more resources than maybe it had in the past, somebody should know about that, right? And the system should proactively reach out to either a service provider or the vendor who sells the solution, or even the end user themselves, and let them know what's going on. And even if it's something that's a known issue, how can it be remediated automatically? One of the examples we commonly use at Stratus is that we have this capability built into our servers. And oftentimes we'll send replacement parts to a customer because the system called us and said, hey, my hard drive is broken. The good news is, since it's redundant, the hard drive, the spare hard drive and the redundant system took over. So really nobody noticed that something was wrong. Well, then a hard drive shows up at the IT administrator's desk, and it's, what do I need this for? And it turns out we had let them know a couple of days ago that, hey, we discovered an error. We're going to send you the system so you can actually easily replace it. And we talk a lot about systems at Stratus, but obviously looking at how the applications interact with the systems is absolutely critical as well. And how do the applications begin to work together? So that's another important aspect, is to really look at the system from a holistic point of view, not like, here's the hardware part, here's the operating system, here's the software pieces or containers. It really is, how do I look at this as a whole system and judge its health from end to end, from the metal all the way up into the applications? And then lastly, as more and more people transition and have a relationship with a cloud or a remote center, a remote private or public cloud, I should say, security starts to become a major issue. The reason that people are still air gapped today, and the reason that a lot of these measures are still in place today, is because of concerns about security. And quite frankly, it's incumbent upon either machine builders, technology vendors like Stratus, or automation vendors to really prove that our systems are secure and will be able to work within the best practices of whatever the cybersecurity protocols are at the organization or company we're dealing with. So it's time for me to turn it over to Matt. Thanks for hearing some of the stories. Hopefully they helped understand what's really going on out there with the world of Edge.
Very good, Jason. Just quickly jumping in here to remind you guys, put your questions in the Q&A. There's a bunch of questions already, but if you have anything you'd like to have clarified or any follow-up questions, we'll jump on that in about 3 to 4 minutes. So please push the Q&A button. And with that, Matt, share the outlook with us.
Sure, thanks, Knut. So the data that we're going to present on this slide is from an upcoming report that we're writing on the state of the IoT, and this is extremely fresh data. The data set is still incomplete. We only have 34 responses so far, but we wanted to share it with the audience so that they can see how overall IT spending is changing, both from 2019 and to 2020, and then from 2021 to 2020. And so you can see on the left-hand side of this screen is the overall the change in IT spending from 2019 to 2020 and the companies that we surveyed. And you can see that the average change is 5.1%, with quite a few companies cutting IT spending in 2020. And we anticipate that a reason for that is because of the coronavirus, and particularly the industries that we've served. And to, I guess, step back and provide a little bit more context, the people that we are surveying for this report are executives and senior managers within IT operations, production, and engineering departments in manufacturing, transportation, and mining companies. So this is still kind of an industrial lens in which we're looking at IT spending. So that 5.1% was the change from 2019 to 2020. And then on the right-hand side of the slide, you'll see that the expected change from 2020 to 2021 is an increase in 10.1%. And you can see many of the people that we surveyed are no longer slashing their budgets, rather they're increasing it and increasing it more. So the expected change is 10.1% versus 5.1%. And keep in mind, this is overall IT spending, so it isn't explicitly edge computing, but I think it's fair to assume that since edge computing is a subset of overall IT spending, that it will follow the same trajectory, and that spending should increase based on the feedback we're getting from the survey respondents in 2021 as this virus is hopefully in the rearview mirror. And I think that the next slide, the kind of final thought before we talk about the next step, it's always important to keep in mind that successful implementation requires looking beyond technology. So this is data from another survey that we did earlier this year on Industry 4.0 and smart manufacturing, and we surveyed 150 end users in the industrial and manufacturing industries, and we asked them what the top Industry 4.0 implementation success factors were. And you can notice by the graphic on the left, that none of the top 5 success factors that the survey respondents mentioned evolve around technology. These are all related to investing in people and training, identifying the ROI, and change management, and ensuring buy-in from the stakeholders. So these soft factors oftentimes have a more important effect on whether or not a implementation is successful. And this is for Industry 4.0, but I think it applies generally within kind of the industrial edge and technology generally. And just to kind of hammer this point home, one of the quotes that we received from the survey respondents is that the successfully implementing IoT technologies is as much about communication and the culture as the technology. So that's coming from a VP at a machinery and equipment company. If you don't believe me telling you, then somebody else with that's a practitioner of this says the same thing. So moving forward, if you want to learn more about IoT analytics and the edge in general, we've got 3 options for you. First, you can watch our previous Edge webinar. I think there'll be a link for that in the chat. And this was done with Bosch. And like we said earlier, this focuses on the thinner edge, the controller and sensor edge. So if you have questions about that, be sure to check that webinar out. The other thing you can do is schedule a 30-minute research walkthrough with IoT Analytics. We'd be happy to walk you through the upcoming Edge report, the Industrial Edge Computing report rather, and kind of show you the ways in which we segment the market and kind of talk about some of the high-level insights that we realized. And finally, the third option is to conduct a self-assessment. So Stratus has published a self-assessment tool that allows people that are deploying edge computing to compare their plans and deployments with their peers. So check that out as well. I think there'll be a link in the chat to that self-assessment tool. And Knut, I think that'll do it, and we can try to power through these Q&A questions. I think we have 15 plus minutes, so hopefully we can get to most of them.
Very good. Yeah, thanks to both of you. Very insightful. We've had a lot of interesting questions come in, and let's see how many we can address in the coming 20 or so minutes. The first question is on the different types of edges and to what degree they are similar or the same, particularly when you look at the PLC type or server. So the question says, is edge similar, same to PLC or servers which are close to the sensors? I hope I'm interpreting this question right. I see it as to what degree are the different types of edges different? I don't know, Matt, maybe that's one for you to start with.
Yeah, sure. We have a better graphic in the report that we didn't put in the webinar that shows the typical compute power that's associated with the different types of edges. Maybe we can go to the overview slide that shows on-premise and controller and computer edge. So the differences are usually, besides the latency and the distance away from the data generating devices, there's compute capacity differences between these different types of edge. So on-premise data centers are expensive, but they have scalable computing power and more computing power. And then if you get down to the controllers, they are typically running ARM processors and don't have the compute capacity to execute some more compute intensive workloads. So and specifically, and I think there's another question about this, about where PLCs are in this, and PLCs are explicitly excluded from this as a rule, but the exception to that is automation vendors are now releasing PLCs that have virtualized environments in which you can run your real-time traditional RS logics or other compute PLC programming languages on one partition of the virtual machine, and then you can also run edge applications like HMIs or analytics on the PLCs themselves. So there's movement there from the vendors to make their controllers a little bit more open, but that is a very, very small part of the overall market. So hopefully I killed two birds with one stone there.
Very good. I have one for Jason here. How do you see web scalers like AWS or Microsoft Azure taking on the edge, and will their scale advantage extend to the edge? I guess that's right. Like to what degree do they come into your ballpark, into your court? I guess type of question. Do you have a view on that?
Yeah, I do. Well, I think that there's kind of a multi-level to that, and what I mean is that while we aren't necessarily seeing a vendor like Azure or AWS coming directly into our customer space, what's happened is that we and other vendors like, say, Aviva and Rockwell have aligned ourselves to different cloud technologies and certify our products to work with them. So what we're typically seeing in our space is that we'll go into a customer environment with one of these partners, and we'll basically be crafting a solution together. And there is definitely a set of requirements and a set of industries who really need something more like what I would say is the thick edge backed by a cloud offering, like Matt illustrated before. So I guess maybe a better way to say it is, our personal aspect is we're seeing more and more solutions be deployed with the cloud providers. From a Stratus perspective, we really focus on either the 100% edge or the thick edge ourselves. So we don't necessarily, when we do see them, it's generally in a collaborative way. And we're pretty happy about that collaboration. I'm sure there's other cases where those vendors, your cloud vendors are actually in the thin edge. They're going straight to end customer or going through different partnerships than we may jointly have. But, it's just not a space we necessarily hit.
Maybe if I could add one additional thing there. When you're deploying some of these cloud vendors' racks on your edge, a lot of the times it's an extension of their IoT platforms or their specific cloud. So if I'm 100% Microsoft shop, then that might make sense for me. But we're seeing lots of vendors that have multiple clouds and they want to run applications that aren't necessarily coupled to the Azure cloud or the AWS cloud. So there's this sort of almost religious question is, do you go 100% in on one vendor, or do you want to have a more vendor agnostic edge that you can move workloads between the vendors and you're not tightly coupled to the hardware from Azure, which is obviously going to be optimized to run on the Azure cloud. So that's one other thing to consider.
Yeah, I would say so. And I would say that what I would say is that it really comes down to how relationships are managed in these companies too. I'd say a lot of industrial companies look to their automation vendor for advice on and guidance and best practices. So I tend to think that also comes into play, is that they're the tip of the spear, and a lot of times they actually have a lot more influence over the architecture than maybe your typical IT business user relationship has. And it's not like the sales department is influencing architecture, whereas operations is.
Yeah.
Good. There is a question on what Matt, I think you mentioned the trend of hardware as a service, and there's a question: is the hardware as a service model a solution to the long life support for industrial edge devices?
Yes.
Curious if any of the two of you want to take that.
I'll touch on it quickly, and Jason, you can hop in too. I would say that I don't know if it's a panacea or a cure for it permanently, but I will say that it's more viable now than it was in the past, in large part due to how portable these applications are. So in the past, if I had, I used to work at Rockwell, so I keep using Rockwell examples, but if I had a really old PLC in a manufacturing plant and I needed to convert it because it's no longer supported, that was a huge effort to go and convert the old PLC software into the new PLC software and spend tens of thousands of dollars doing a full migration. Well, if my PLC software or my HMI software is completely virtualized and in the container on a generic industrial PC or a generic data center, then if that data center becomes not supported or the industrial PC is no longer supported, then this changeover will just be simply moving the container from one device over to the other, which should reduce system integration and change costs associated with that. So I think that's my answer to the question. Jason, I don't know if you have another perspective.
I do. I'd say that that's the attempt. I think what's happening is vendors are offering these solutions in an attempt to try to blur the line a little bit between in life cycle, right? I guess the only thing I'd suggest to think about with that is that so far what we've seen is that the edge as a service models are largely they're largely kind of pricing plays. And what I mean by that is it's somebody sits down and says, this thing costs this much to acquire. We expect its life cycle to be this. Why don't we offer it at this price point? But when you start to think of things as a service, right? If you look at like software as a service, there's actually a transfer of control, right? And I think that is something that a lot of these edge hardware service plays don't fully understand, is that when you start to have a customer move to that, there's this implicit transfer of control over to the vendor. Now the vendor basically is operating and managing that system, right? So, and I think I see it as a major opportunity for vendors like Stratus. I also see it as a major opportunity for vendors like Rockwell or Honeywell or any of those folks too. But you really have to kind of take a look at those offerings and kind of parse them apart and figure out, is it, hey, am I just doing a fancy way to finance the same solution I have? Or am I actually going to be getting a new solution where basically I've outsourced a little teeny tiny portion of my environment to somebody else? And if I do that, then things like lifecycle management are no longer my problem. They're the problem of that vendor. Just like, you don't know when Salesforce, or maybe somebody in your company does, but if you're using Salesforce.com, it gets upgraded, it gets fixed. You have no idea. You're just using the app, and that's what as a service really means. So I think there's a little bit of marketing magic going on in this, and it's early in the stage. We're keeping our eye on it very closely, and we're listening very intently to what our partners want to do, since our business model is driven around partnerships versus us selling direct to companies.
Very good. All right, Jason, we're getting a lot of questions that are specific on the Stratus solution and the case study, and sometimes in relation to the case study. So I'm just going to read a couple of you to here. What kind of ZTC did you use for the Bradbury case? Is it FT or HA?
It's the fault tolerant version. It's the higher end one.
Okay. Then there is another question here. Which platform has been used in these project use cases? It looks like, is that question clear? Might be a little bit unclear what's meant by which platform has been used.
It's a mix. Bradbury's a ZTC user. The Allen Weiss one at the end is an FT server user. And the liquid petroleum one that I mentioned is actually a mix. They use a little of both.
Okay. Let me just quickly check. Okay, let's go a little bit broader again. Someone was asking about the use case of using IoT Edge components in an ATM machine. So the question is, can we use IoT Edge components in an ATM machine where they can track the exact problem at the machine? This will help them with the maintenance, and how much would that cost? I mean, it's a very specific kind of use case. Don't know if all of this can be answered.
I don't think I can answer all of it. What I can tell you is that
is this something that you guys cater to?
I don't think we've ever done an ATM machine, but we've done things like bomb scanning machines in airports and so forth. And it really depends. It really depends on the software solution. At that point, there's some of the things about predictiveness and so forth. It really is driven by the software. What we're really doing is providing an embedded platform upon which the software can run. So the mileage varies drastically between machines and in terms of what's happening. But you could definitely see, there's solutions out there where you could deploy a small edge computing device with any type of embedded machine, and it becomes a software problem at that point.
Good. Here's a question maybe for both of you. What type of architecture would you recommend when using thin micro edge devices on remote locations? And what are recommendations for device management of these devices when they communicate over the internet? So again, very specific question.
Yeah, I can take a stab at that first, Jason. So I think depends on what you're trying to do. So I'll give you two examples of thin edge architecture. So you could, if you're in a situation that requires battery powered devices, you could have a local mesh network of low power wide area network sensors that come back and centralize into some intelligent networking equipment. So this would be, the micro edge would be the sensors, and then they would all have a local area network back to the networking equipment. And then from there, you could send the data over CAT-M or 4G, depending on how much data is being sent. So without knowing more about the specific bandwidth and latency and power requirements, it's hard to give an exact answer about the specific architecture. But the device management question is an important one. And I think there's a couple of different ways to go about device management. You need to consider managing the physical devices themselves, and you also need to consider the management of the applications themselves. And if you're going with a gateway vendor, a lot of the times these gateway vendors will have device management platforms that manage both the device and the application. But at that point, you're very much locked into the gateway vendor ecosystem. You have to use their hardware, and sometimes you even have to build the application on their software platform, which may not be as open as you want. So you need to, and we segment the edge platform vendors, so these edge application management platform vendors, into 4 quadrants in the report, and I think we have 60 or something of them in the report. So depending on how diverse your field devices are and how locked in you're okay with being with the vendor, there's some options there. But you need to make sure that when you do device management, you're not just managing the firmware of the device, you're also managing the application, which could be analytics or any sort of application at the edge. So I think that's my answer.
Jason, do you want to add anything or jump to the next question?
I think Matt hit it really well. So I don't have much to add to what he said.
Let's stick with one more architectural question. And before I get there, I would like to ask everyone attending to please give us 1 minute, spend 1 minute, just fill out the survey, let us know what went well, what didn't, any improvement ideas. Alice is going to share that in the chat right now. So if you may, before you hop off, just quickly click on that. It helps us a lot. And the other thing I would say is, as we have a ton more questions, I would offer to extend this by another 5 to 10 minutes. We'll stay on. Obviously, if you have to jump off at the top of the hour, do so. But I would say we'll be spending another 5 or 10 minutes going through some of your questions. With that, there's one more architectural questions. Is latency the main decisive factor to decide between thick and thin edge, or are there other factors to consider?
Oh, there are several factors to consider. Jason, maybe you take this first and kind of talk about what goes on with your customers, and then I can jump in.
I think that there's a, when a lot of people talk about thin edge, I'll start there for a second. There's a lot of discussion about latency and things like that as to should I do thin edge or not. When you move to more of a kind of a thicker edge, what you're finding is you start to get into a lot of different issues in terms of, at that point, you're probably utilizing multiple solutions. So now you're starting to talk about workload consolidation. Now there's the connectivity requirements change. So the way you secure that site from a cybersecurity and a physical security is also very different, because you're probably containing and storing more data locally, which basically means you have to start looking at different types of security requirements, more robust security requirements. Then you have to start, those are just the technology issues. Then you start getting into people issues. The nice part about the thin edge is that the devices are relatively standardized. It's kind of like, in a lot of ways, like deploying a consumer device, right? Or, you plug in the network and green lights come on the back and it just kind of sits there. There's no human interface to it, really. It's really just collecting or operating data. So I'd say that there's a lot of people issues that come into it in terms of who's operating, who's managing. And then the last one, I think, is really the kind of more futuristic use case, which is about control. A lot of edge use cases today are very much geared towards data collection, and where we start to see it is a lot, and we'll call it more of a SCADA type of system. But the reality of it is that when you start to get into a device now controlling a machine instead of a human controlling a machine, there's a whole nest of new issues that are starting to spring forth from that in terms of understanding not only human relationships with the machine and what the responsibilities are, but also just in terms of the requirements put on those machines. Often those requirements are starting to still be talked about in a very latency type of sense, which is appropriate because when you start getting into things that could potentially cause harm or damage, you want to make sure that you're getting absolutely the best possible safety requirements. So that's still kind of, I would say that's still kind of emerging. That's the emerging part of it, but everything up until control, really, it is a bit of a different playing field when you go there.
Yeah, and just to put on that, I think the answer is it depends on the workload that you're running on the edge. And Jason did a great job of articulating why control is an important one. Analytics is a different type of workload that you can run on the edge. And depending on which workload will decide which factor, either availability, security, latency, data throughput, is going to dictate the architecture. So
yeah, the other thing that's starting to pop up now in some of our solutions that we don't specifically go after it in terms of seeking out opportunities there, but we're seeing a lot of people deploying a control solution alongside like an augmented reality solution for training and operators support. So that's kind of a new space where probably thinking about something thicker, right?
Yeah.
Good. Matt, there have been a couple of questions related to the Industrial Edge Computing report mentioned. One is legacy PLCs are an important integration challenge. Has the report considered tools for automating discovery of legacy PLCs?
So there's a sub-segment in the market on data ingestion tools, which range from data pipelines to OPC servers. The automated ingestion, I don't know if we've specifically looked at that case, but it's an important part, and it's related to sort of the standards movement that's going on in the legacy PLC environment, trying to wrangle all these legacy OT protocols into a format that can be easily consumed by upstream applications and data lakes, and this idea of data ops to ETL the data from these controllers into something that's easily consumed upstream is really important, and we do touch on that in the report.
And the related question is, someone was wondering if there's a breakdown between OEMs, SIs, and end customers, and also breakdown based on verticals.
Yes, for verticals, no for SIs, but for OEMs and end customers, we mostly are looking at the end user verticals in which these systems are deployed in. But for the machinery vertical, we consider that vertical to be both a consumer of edge computing and a reseller of edge computing. So if I'm a CNC maker, I could put an industrial edge computing device on my machine when I sell it to the automotive end user, and I could also use edge computing in my manufacturing process. So those are ways in which we've segmented the market, but we don't explicitly go through the distribution channels for each of the different types of edge to figure out if they're going to OEMs, end users, or SIs.
Yeah. But I will say that in the edge computing space itself, we're seeing a shift where people are starting to look at, the as a service thing is also prompting people to go, well, maybe I should do my compute at the machine level and again, pass that control over. So I would call that an emerge. We've done some proprietary studies and research here, which made us decide to go pursue that market, which I can't share. But what I can tell you is it's emerging, and we see it as kind of a big source of big driver of growth down the road. Maybe not in the next couple of years, but long term, that's a long-term growth driver.
By the way, I still see that a lot of people are still on. I mean, we're 5 minutes past the hour, so I'll spend another 5 minutes trying to get to some of the other questions answered. And just to remind everyone, the recording will be shared. There was a couple of questions about this. So if you have to hop off, you will get the link to the recording. If you had a question, we'll try to get to that now. There was one question I couldn't really say what that was really about. It asked, what about ABB automation? Do you have a certified for DCS? And this was
Sure.
I guess, for Matt, because this was the question. Maybe not, because the question was posed when Matt was speaking. So I'm not entirely sure.
I think I know what that question might be. Is that Matt mentioned that there's a pre-configured Aviva solution that we have, and somebody asked, do we have one for ABB? And it said ABB or DCS. So we do certify on multiple DCS solutions out there, so people can deploy DCS software on our systems. However, ABB is not one of those partners at this time, but we do work with Emerson and Rockwell, and Yokogawa for that matter. So we do have great stories and solutions in the DCS space, just unfortunately not with ABB. But if you want that, you could call ABB yourself. Our business development people do all the time. so we'd love to hear some demand if you have it.
Yeah, very good. I realized there were a couple of questions on the topic of IoT gateways. So one question reads, in which category do you see smart IoT gateways? They are neither networking equipment nor controllers, although they live in the machine cabinet.
Yeah, so we segment the networking. So in the report, we have even further segmentation into computers and networking equipment. And I think, based on his description, that this would fall under our intelligent networking equipment category. So think routers and gateways that also can run edge applications on them. So they're not really controllers, even though they could, I guess, technically run some sort of software-based controller on them. But they're in this like middle ground. It's not quite a computer, but it's not really a controller, and it's not a pure networking equipment. It's not your just regular VPN router. So there's a lot of vendors that are offering that now and opening up their operating systems in order to be able to run these compute resources on them. Right? Cisco comes to mind, and Hilshire is another company that kind of enables that smart IoT gateway.
You can also see a future where hardware technologies like PCI Express can allow running a gateway within an industrial PC. There's some stuff going on in the hardware space that really blurs the lines as well. We're something our research teams are looking at in terms of how we deliver fault tolerance as well.
This one might be a bit specific, but someone inquired about the average price for industrial IoT gateway and what the percentage share of a total industrial IoT project is. I mean, this is obviously probably varies quite a bit. I don't know if anyone, we can jump to the next one if you think this is too specific.
Yeah, I think without knowing what the hazard requirements and the temperature requirements and those sorts of things, it's really, really tough to give a general answer.
Yeah. There are, as we oftentimes see, a couple of questions about some of the new kind of connectivity technologies. So I'm going to read a couple of questions here. One is, with expanded network availability and reliability coming with the prevalence of 5G, NB-IoT, LTE-M, and others, do you expect to see more migration to thin micro and cloud architecture? And do you expect industrial markets to take advantage of this quickly, or will it be a slower adoption as is typical in the industrial space?
So I'll give that a stab first. So I think that the answer is yes. We expect to see adoption of maybe not all of those technologies. I don't know if I can touch on 5G and LTE and all these things, but maybe we'll start with the low power wide area networks or the kind of CAT-M type connectivity architecture. So there's two cases and two kind of categories in which we're seeing this being adopted already in the industrial space. One is from OEMs who are putting these intelligent edge gateways on their equipment and allowing the enablement of new services. So if I have, I'm an equipment supplier, I sell to, again, like say an automotive company, and I want to guarantee uptime for my equipment. This is something that can be done with narrowband IoT if you're only sending a little bit amount of data, or CAT LTE. So that these kind of new technologies can enable those sort of use cases. And then the other use case that I think is especially enabled by these more low power technologies is companies creating these sensors with built-in connectivity that run outside of the traditional DCS or control system, because integrating a single sensor into an existing DCS system can be extremely expensive. So what we're seeing is companies bolting on narrowband IoT sensors to their motors and sending that data via gateway or directly, if they're narrowband IoT, up to a cloud. And then vendor manufacturers are saying, we have the subject matter expertise to know that when the vibration of your motor exceeds this threshold, to notify you and prevent a maintenance downtime issue. So those are just two examples that we're seeing currently happen right now. And we anticipate that vendors and end users will get even more creative with those technologies moving forward to create value. So I don't know, Jason, if you wanted to add something as well.
I would just say it's very industry specific. There isn't a really easy way to do it, or even within the industry. I'd say that, for example, in midstream oil and gas, it's not talked about anywhere near as much as in the, what they'll call upstream, which is where they do the gathering of the resource, right? I think it's, it really is going to be a function of how remote you are and how much data you're going to be passing, but certain verticals are looking at it very extensively.
Yeah, and maybe I can add to that. I mean, we as IoT Analytics, this is one of those topics that we will most likely zoom in the coming months as a topic of interest in terms of these new private networks, 5G and so on, are used in industrial. So it's one of those areas where we will do a double click from a research perspective as well. We already have to some extent, but we'll do in greater depth. Good. I think, I mean, we're now 11 minutes over. There's still a couple of questions. I don't know, Jason, Matt, how you feel. I can see some fatigue. We don't have that many people on anymore. If you want to take one or two more, we can do that. Otherwise, I'd say we will try to get back to these people in an email.
That might be best.
Yeah. Well, with that, I want to thank everyone. I want to thank both you, Matt and Jason, for a really interesting discussion. I think this was excellent. Yeah, if you haven't done so yet, please give us your feedback. The link was shared recently. The recording will be sent to you shortly. And have a great day. Thanks, Matt. Thanks, Jason. And bye, everyone.
Thank you.
Bye-bye, everyone. Thank you.